Okay, next one. Let's look at direction of the relationship in detail. X is husband's height, Y is wife's height. You know, taller husband marry taller wife. For example, Yao Ming, you know Yao Ming, right? The former NBA player for Houston Rockets. How tall was he? 226 centimeters tall. How tall is his wife? Ye Li, 194 centimeters tall. Okay? Nobody in this class taller than what? His wife. So we all shorter than Yao Ming's wife. Listen, not Yao Ming, okay? Yao Ming's wife. Is that it? Generally speaking, if you observe husband's height and wife's height, what do you find? You find taller husband marry taller wife. Shorter husband marry shorter wife. When you make a scatter plot, you find the scatter plot is football shape. And this suggests what? You can use the line to fit the data set. And the fitting line has a positive association. Positive association, positive slope. The fitting line has a positive slope. That means what? As x increase, y also increase. Okay? Also increase. So that's what we say positive direction. Okay? Now, if this line is y equal to average y, this line is x equal to average x. These two perpendicular lines divide the space into 1, 2, 3, 4, 4 different areas. Okay? 4 different areas. And this point is called the point of average, in the center of the data set. Okay? Now, let's look at this picture very closely. A key observation is that when this is positive association, we're going to find more observation in area 1 and 3. You're going to see more observation in area 1 and 3 than those you see in 1, 2, and 4. Can you see that? There are more observation in area 1 and 3 than those in what? Area 2 and 4. That's why the feeding has what? A positive association. Okay? Now, this further induce that. Let me show you, okay? Let me show you. If I cover this part up, what can we say about those observations here? I call them larger x. Why I call them larger x? Because there's x coordinates. Their x coordinates are all greater or equal to average x. So they are larger x. Larger x are related to larger y. Why I call them large y? Because their y coordinates are all greater or equal to average y, right? Large x are related to larger y's, but also related to what? Smaller y's. But large x are more related to what? Larger y. Can you see that? Because you have more observation in area 1 than those in what? In 4. Similarly, you have, look at this side, okay? Look at this side. I call them what? Smaller x. Why I call them smaller x? Because their x coordinates are all smaller or equal to what? Average x. Smaller x are related to larger y, but also related to what? Smaller y. But smaller x are more related to smaller y. Because you have more observation in area 3 than those in what? In 2. Is that okay? So put in our context, okay? Shorter husband, right? Shorter husband. Marry taller wife, but they also marry what? Shorter wife. But more shorter husband marry shorter wife. Okay? Look at the other side. This is what? Larger x are related to larger y's, but also related to what? Smaller y. But larger x are more related to what? Larger y's, right? That means taller husband marry taller wife, but also marry what? Shorter wife. But more taller husband marry taller wife. Because you have more observation in 1 than those observation in 4. Is that okay? So this is a conclusion, okay? This is a conclusion. A key observation. If this is positive association, then there are more observation in area 1 and 3 than those in area 2 and 4. So that means larger x are more related to larger y's. And smaller x are more related to smaller y. Is that okay? How about negative association? It changed. larger eggs are more related to smaller wives, and smaller eggs are more related to larger wives. That's negative association. Is that okay? You want to copy? Go ahead.